Proportional valves and its types are proportional pressure relief valve, proportional pressure reducing valve, proportional directional control valve. The proportional pressure relief valve works same as conventional pressure relief valve, but springs are replaced by proportional solenoid. The input current to the solenoid energizes the coil and produces an armature deflection proportional to input current. This armature deflection exerts a force on the poppet. The poppet keeps the valve closed until the inlet pressure at port B overcomes the force by armature deflection. When the inlet pressure overcomes this, the poppet valve opens and the valve varies the pressure of the valve. Proportional pressure reducing valve works same as the conventional pressure reducing valve, but the springs is replaced by proportional solenoid. When solenoid is energized, the armature will deflect and move spool towards right. This action opens control orifice A and allow flow from A to port X. The outlet pressure of this valve depends on the opening of control orifices A and B, which in turn depends on the input current to solenoid. Thus, by proportionally varying the input current, the action opens the control orifice A and allow flow from A to port X. The outlet pressure of this valve depends on the opening of control orifice A and B, which in turn depends on the input current to solenoid. Thus, by proportionally varying the input current, the operating pressure can be reduced. Proportional direction control valve. If you are familiar with direction control valve, that is DCV valve, so it's specify and arrange the flow in a specified direction. So that is proportional direction control valve. When solenoid 1 is energized, the pressure is applied to port X. This causes the spool to move towards right against spring force. It allows fluid flow from port P to port B and from port A to T. When the solenoid is de-energized, the control spring centralizes the spool back to normal position. Similarly, when solenoid 2 is energized, the pressure is applied to port Y, which causes spool to move towards left against the spring pressure. Now fluid flows from port B to port A and port B to T. When de-energized, the spring centralizes the spool to normal.